This is a recording for math analysis of section 10-2, part 1, and I will be absent when you go over this, so hopefully you followed the subnotes for the other things you've had to do this hour. So take a moment, and this is 10-2, arithmetic sequences and series. I almost like this section better than the last section because we focus on a particular kind of sequence and series. The essential question is, can you find the nth terms and arithmetic means of arithmetic sequences? And then also, can you end the sums of arithmetic series? If you need more time to write this heading, you can pause this recording. Otherwise, I will be moving on. I will give you a moment or two to do that. Okay, if you need more time, pause this. Otherwise, I am moving on into this section. So this is going to have some vocabulary, arithmetic sequences, common difference, arithmetic means, first difference, second difference. Actually, these first differences and second differences we won't be doing, but we will do arithmetic series. So we're going to focus on sequences and series, and then you'll have some assignments just on those parts. So an arithmetic sequence is a sequence in which the difference between successive terms is a constant. So it's a sequence in which the difference between successive terms is a constant. And then that constant is the common difference. You do want to define this because our next section is on geometric sequences and series, so you want to be able to know what the two different things entail. And this common difference is denoted D as you're going to go through things and look at this. So that's what you need to know, those two definitions, an arithmetic sequence, and that has a common difference, and that common difference is called D. If you need to see that longer, pause this. Otherwise, I'm moving on to the first problem. Okay, this is the first problem, and it says determine the common difference and the next four terms of the arithmetic sequence. So we're focusing exactly on arithmetic sequences. So in this case, we know that there's going to be a common difference. And the easiest way to find that common difference is to just take a term and subtract the preceding term. So negative 36 minus negative 53. So we'll add positive 53. And so D is equal to 17. So essentially we're adding 17 to get to each from one term to the next. So we've got negative 53, negative 36, and negative 19 as our first and three terms. And then we're to give the next four terms. And so we just successively add 17. So negative 19 plus 17 is negative 2. Negative 2 plus 17 is 15. 15 plus 17 is 32. And 32 plus 17 is 49. And I don't know if in earlier days I've told you this, but there's an easy way to do that on a calculator, graphing calculator. If you go negative 19 and then enter, and then just go plus 17, so it'll have answer plus 17, enter. As long as you put that beginning number, or in this case, that's the third number of that sequence, as long as you enter that in your calculator and push the enter, then if you tell it to add 17, then you can just repetitively press enter. And we'll do this later in the lesson as well. But just a little reminder or piece of information about how you can do these problems as you go along. And so this starts out pretty straightforward. The next thing I'd like to do is, oops, before I do that slide, I'd like to go over the fact that, kind of think about that problem that you just encountered. And as we think about what those values were and that kind of repetitive adding of 17, I want you to think about the fact that, and maybe I'll just write that answer or that problem again right here. It was negative 53, negative 36, negative 19, negative 2, 15, 32, 49, and we know it keeps going. So we take our first term, and if we call that term a sub 1 is our first term. And in this case, it was negative 53. And then to get our second term, we take that a sub 1 plus that common difference. So we add 17 to get to that next one. And then think about, to get that term after that, so this negative 19, we could think about using our negative 53 and adding 17, and then adding 17 again. So our third term could be a sub 1 plus d, which is plus 2d, and that'll be the third term. And then I'll just go a couple more terms as we're looking at that. And then I can think of that negative 2 if I wanted to start at the negative 53, that beginning term, add 17, add 17, add 17. So that's a sub 1 plus 3 times that common difference for the fourth term. And I want you to look at that relationship and notice that if I wanted maybe the 12th term, that really I could think of that as a sub 1 plus, and how many of those common differences would I have had to add? Well, look at this pattern. The first term I didn't add any common difference. The second term, I added 1 common difference. The third term, I added 2 times the common difference. Fourth term, I added 3. So it appears as though we're using 1 less, so that would be 11 times d, and it indeed is. And so let me get rid of all that yellow a moment. And so then we can say that the 12th term would be a sub 1 plus 11d. And then, of course, if we wanted to make it into the nth term, so that we don't know what that is, well, we can take a sub 1 plus, well, that is n minus 1 times d. So that, that gives us a way to find that nth term without having to kind of go out term by term by term and repetitively adding 17 all the time. And so there are two kinds of ways that we're going to get the nth term. This method is called, oops, this method is called the explicit. And let me just write that, E-X-P-L-I-C-I-T. That is the explicit form, and we can just plug in things and kind of think about what's happening. There's another form called the recursive form. And if you remember when I told you how you could use the calculator, put in that first number. We didn't put in necessarily the first number, but then just go and then plus 17, enter, enter, enter. Well, the recursive form is to define what a sub 1 is. And so I'll just put a sub 1 equals in a blank. And then say a sub n is going to be the previous term, which is a sub n minus 1, plus that common difference, d. Okay? And that's the recursive form. And we'll want to be able to give both of those forms as we do these problems with arithmetic sequences. And so here's the next slide. If you didn't write those down just now, you'll want to write them as you look at this slide. We just kind of went through that top part of this with our previous problem. And this is to find the nth term of an arithmetic sequence. And I am going to get rid of this extra one I have there. And to find the nth term of an arithmetic sequence with the first term a sub 1 and the common difference d is a sub n equals a sub 1 plus parentheses n minus 1, close the parentheses, times d. And again, this is called the explicit version because you will have to know that. And so I'm actually just going to write that right below here. A sub n equals a sub 1 plus n minus 1 times d, and that's called explicit. And then it's not on this slide, but we've just talked about it, and I know you'll have to have it. If you are given an a sub 1 and then a sub n, I'll slide this up a little bit, then a sub n is equal to a sub n minus 1. So that subscripting means, you know, if n is 5, you're going to use a sub 5 minus 1 or a sub 4, that previous term, plus d. And the subscripting is the n and the n minus 1. And the other thing I just want to bring to your attention, and maybe I'll just make this a little bit bigger just so that you can see it, is we're talking about having a sub 1, and so it says explicit formulas if a term other than a sub 1 is given. So that's going to happen to you. The explicit formula for finding the nth term of the sequence needs to be adjusted, and this can be done by just subtracting the number of the term given for n. For example, if a sub 5 is given, then a sub n is equal to a sub 5, and plus n minus 5 times d. If a sub 0 is given, then a sub n equals a sub 0 plus n d. So just kind of some things to be aware of. Oh, and I see that I forgot to write. This version is the recursive. So make sure that you know those two, and as we move through things, you'll want to remember that as we go. If you need more time to write that, pause this. Otherwise, I'm moving on to the next problem. For problem number 2, it says find both the explicit formula and a recursive formula for the nth term of the arithmetic sequence. So I will write this one. This is 14, 3 comma, negative 8 comma, dot, dot, dot. So we need both formulas as we go through this one. And so the first thing I just want to identify for myself, a sub 1 is that first term, and so that's 14. My common difference, d, I can take any term and subtract the previous term to get that common difference. So 3 minus 14, so d is negative 11. So once I have that information, I can write my two formulas as I go. And so first we'll do the explicit formula. And for that one, just a reminder that is a sub n equals a sub 1 plus parentheses n minus 1 and parentheses d. And so a sub n means that's the general one. A sub 1 is 14 plus, we leave n in there, n minus 1, and our common difference is negative 11. And then just we want to do algebraically some cleaning up. Distributive property, combining like terms just to make it in a little easier to see form. So 14, if I were here, I'd have you distribute for me, but, I'm going to get rid of that plus. So when I distribute from the back, negative 11 times n is minus 11n. Negative 11 times negative 1 is plus 11. Combining like terms, a sub n equals 14 plus 11, so that's 25 minus 11n. So the explicit form of this recursive, or excuse me, of this arithmetic sequence is a sub n equals 25 minus 11n. And, kind of think about that. That's the slope. And actually, this was a sub 1. So kind of think about yourself, to yourself, these are linear relationships. That common difference is like my slope, negative 11. And think about the where that would cross the y-axis. That would be at a sub 0. And so if you're going this way, instead of subtracting 11, you add 11. So 3 plus 11 is 14. And then if you add 11 here, you get 25 as that 0 term. So really think about that linear relationship that you're getting, because you know a lot about linear relationships. So that can help you just remember you know a lot about this already. And then we'll do the recursive formula. And the recursive formula for this one is just to list a sub 1. Because for the recursive one, we have to know what that initial value, sometimes that's called a seed value. We have to know what that initial value is, because otherwise we could get a completely different sequence. And so a sub 1 is 14, and then a sub n is just a sub n minus 1, so make sure that's kind of subscripted, and then plus d, which in this case is negative 11, so we'll just say minus 11. And so that recursive form kind of has a 2 parts to it as you go. So make sure that you're taking good notes and writing things down about these different versions of this as you go. Now, moving on to number 3. For problem number 3, they're asking us to find the 41st term of the arithmetic sequence. And so this is, oh, by the way, this is 3a, so there must be more than one. 11, 4, negative 3, negative 10, dot, dot, dot. And often on tests and quizzes, you'll be asked things like, find some big, long term that's pretty far out there, because, if you do that recursively, it's just going to take you a while. It's hard to remember, keep count accurately of how many times you've kind of done that. So we want to be able to use the explicit form in one like this, I would say, especially if it's the 41st term. If it was the 8th term, go ahead and kind of figure that out. But let's just remember what we've got. A sub 1 is 11 in this case. Our common difference is any term minus the previous term. So 4 minus 11. So our common difference is negative 7. I'm going to use the explicit version of this. So a sub n equals a sub 1 plus parentheses n minus 1d. If you write these formulas every time that I'm writing them, it will help you, your brain kind of grasp onto them, and it'll help you remember them as you go. So we want the 41st term, and since this 11 was a sub 1, then we want a sub 41, and so I'll subscript it that way. A sub 41 is equal to, and now I should be able to put all the things in that I need to know. And so actually I should have said n is 41. So a sub 41 is a sub 1, which is 11 plus n minus 1, in this case 41 minus 1, times that common difference, which is negative 7. And then if we just do that on our calculator, 40 times negative 7 is negative 280, and then add 11, or just type that in, we get a sub 41 is negative 269. So just check that you can do that, of course, on a calculator. It's not like in that last chapter when we have a lot of, trig formulas to enter in. So think about what's happened in this problem, and think about the fact that you have many variables. And so I'm just going to talk about that before I go on to the next one. We have a sub n, we have a sub 1, we have n, and we have d. So there's 4 variables there, and we want to be able to figure out at least 3 of them by the information that we have, and then we can generally find the 4th one. So here's the first term, and d we could get pretty easily. In this case, we were told what n was going to be, so it was all fine and good. So, but I just want to point out before we go to the next problem that if out of those 4 things, if you find you know, or you can use the information given to find 3 of those, then you can find that 4th one as well. So here's 3b, and for 3b, it says find the first term of the arithmetic sequence where a sub 44 is 229 and d is 8. So we have a sub 44 is 229 and d is equal to 8, and we have to find the first term, a sub 1. So I'm just going to remind you that we can count that a sub 44 as kind of knowing 2 things. We know a sub 44, and we also know that it is the 44th term. So that also tells us that n is 44. And so we'll use that explicit formula again. And really, you know, kind of think about this. If you can't remember the explicit formula, you could start at 229, and instead of adding 8 to go to the terms after the 44th, you could keep subtracting 8 until you get down to a sub 1. And again, it's that counting and keeping track of things as you go. So here is our formula. A sub n equals a sub 1 plus parentheses n minus 1 in parentheses times d. So I'm just going to rewrite it one more time with just putting in some things that I'm going to use in this one. I wouldn't necessarily do that, but since I'm not here to tell you. So I know a sub 44, that's going to be a sub 1 plus, and that means n is 44. So 44 minus 1 times d. I'm just doing the n in there just to make sure you know that's what's happening. So then I am going to substitute in the things that I know. So in this case, let me just realign the board how I want it. In this case, a sub 44 is the 229 equals a sub 1, which is what we're trying to figure out, plus 43 times 8. And then it's just a matter of solving that. So 229 equals a sub 1 plus, and 43 times 8 is 344. Subtract 344 from both sides, and negative 115 is a sub 1. And so we can find n, we can find d, we can find a sub 1, we can find a sub n, as long as we have something to go by as we're looking at that. Now, the nice thing about these relationships, let me go to the next one, is these, since they have just a common difference, if we're given like 2 terms and we know there's a certain number of terms in between those, we can find those missing terms when we have this an arithmetic sequence. So if we have 2 non-consecutive terms of an arithmetic sequence and they are known, then the terms between them can be calculated. And these terms are called the arithmetic means. In the sequence below, 17, 27, and 37 are the arithmetic means between the 7 and 47. So they've given you even extra things, but even if they just gave you this 7 and 47 and you had to find the arithmetic means in between them, that is those 3 as we go through. And our next problem is to do an arithmetic mean problem, and I will explain that as I go along. And again, everything we do in this section is about arithmetic sequences in series. The next section is geometric, so there are different sets of rules as we go through these. So make sure you're writing, this is the arithmetic means that we're finding. Oops. And I forgot to say, if you want to look at that further, you can pause that. Otherwise, I'll be moving on to the next slide. This is number 4. It says, write an arithmetic sequence that has 5 arithmetic means between these two numbers. So I'm going to ask that you write a directive to yourself so that you know this is what it's asking. Find 5 arithmetic means between 6.2 and negative 1.6. So that's our directive for this problem. And then I'm going to set that up just so that I'm going to pretend that is my full thing. So I've got 6.2. I'm going to go, and then I'm going to draw 5 blanks for my 5 terms. 1, 2, 3, 4, 5. And then my last number is that negative 1.6. So then I'm just going to remind myself, because this is fairly new to us, this is a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, a sub 6, and this is a sub 7. So 5 arithmetic means in between two numbers gives you seven terms altogether. So what I want to do is I want to figure out my common difference, but I have a sub 1, I have a sub 7, so then I would know a sub n when n equals 7. And so I'm going to use my explicit formula. So a sub n equals a sub 1 plus, oops, equals a sub 1 plus parentheses n minus 1 d. Wow. And now I'm going to kind of think about these and I'll maybe just list out my information that I'm going to use. So a sub 1 is 6.2. A sub n is going to be a sub 7, which is negative 1.6. N equals 7, and d is what I'm going to figure out as I use that. So now I'll just kind of put the things in that I know. A sub n is negative 1.6 equals a sub 1, 6.2 plus n, which is 7, minus 1 times d. And I'll slide that up a little bit so that I can do my work. And as I go through that, negative 1.6 equals 6.2 plus 6d, subtract 6.2 from both sides, and I get negative 7.8 equals 6d, divide by 6, and I get negative 1.3 is equal to d. So then once I have that, the next thing that I do is simply take my a sub 1, which is 6.2, and keep adding on my common difference, which is now, now I know what that is, negative 1.3. So 6.2 minus 1.3 is going to equal 4.9. 4.9 minus 1.3 equals 3.6. 3.6 minus 1.3 is equal to 2.3. 2.3 minus 1.3 is equal to just 1. And let me slide that again. 1 minus 1.3 is negative 0.3. And then I might also just check that negative 0.3 minus 1.3 is negative 1.6, just to notice that I do get my value to be the same there. And so then I can just fill these in or write them however I need to. So that's 4.9, 3.6, 2.3, 0.3, and oh, I missed one writing here. Oh, I missed my 1. Sorry about that. 2.3, 1, 0.3, and then, or excuse me, negative 0.3, and then negative 1.6. Okay, to end the hour, I would like you to do a little exercise, mathematical exercise. So no calculators. The teacher should give you a little quarter sheet of paper, or if not, you can just tear out a piece of notebook paper. And no calculator and no talking. No calculator, no talking, and just give the teacher your paper when you're done. And it is as quickly as possible, add the numbers from 1 to 100. And so take a minute and or see if you can do that, hand those in, and then you can work on things for today.